All right, welcome to Pipeline Academy CAD Essentials Lesson 3. We have Aaron back
Hello?
due to popular demand. So on the last lesson, we made our coaster look a little bit nicer on the desk, and we got feedback that it looks great, and our boss wants more of them, but the problem is they don't stack very nicely. So in this lesson, we're going to learn how to create an assembly and and we're going to build a holder basically for these coasters, and we'll learn some new stuff about SolidWorks and design principles along the way. So if you're following along, you can download the files in the link in the description. I've done that here, and I'll start by opening the coaster on desk assembly. So here is the coaster that we've been working on, and if I open this, this should be what you see when you open it as well. We need to start by creating a holder for this, and then we can create an assembly that shows this coaster inside of that holder. So the first thing we do is we need to create a new part. So I'll do that by selecting the new option and hitting OK because part is selected, and we'll get started. So because our holder is going to be set down on the table, I'll probably just start by drawing a profile of it and extruding for now. We'll start by just making a big block and cutting a hole in it so we could drop a bunch of coasters into it. So in this case, I'll create a new sketch on that plane like we've done in the past, and I will draw a rectangle.
Brandon, quick question.
Sure.
At this point, do we know like more or less what this holder is going to look like, or are we just kind of starting from scratch here and we'll figure it out as we go?
Yeah, good question. That's sort of the point of this lesson is we're working through it as we go. We have a mental picture of an object that has a hole in it the size of a coaster that drops in, but we're not sure what we're going to make. Right now we're kind of just making it up as we go, and we'll probably reach a point where we decide that we've learned some things, and maybe we'll go back and update it with our new knowledge.
Got it. Okay, thanks.
So in this case, I know that I need to make a big block of material that I could cut a hole into to drop the coasters. So I'm going to start on the top plane and create a profile that I can extrude. I'll use the rectangle this time because that's what a big block is. It's generally a rectangular shape. There are multiple rectangles that you can use, but I'm going to use the center rectangle because that allows me to click where the center is of my rectangle, and I'll click on the origin, and if I let go and then move my mouse, it will draw a rectangle from that center.
And why do we care that the center of our rectangle is on the center of is on the origin as opposed to 10 inches away from the origin?
Well, something that is just arbitrarily in a random place away from the origin is kind of difficult to plan for. Let's say, for instance, I draw a rectangle out in space over here. If I needed to make sure that it was impossible for me to accidentally change the shape of this rectangle, I'd have to start adding some dimensions, and it would take me a lot of dimensions to make sure that this can't move. So let's say I fully define this rectangle out here in space. It's still a blue sketch, which means it's not fully defined and it can move around. And then if I build other features and then later come back and move this around, those features might break. So this is just generally considered bad practice because you don't have a good reason to put it here. Generally, you want to think if you have a good reason to do something. In this case, there's no reason to put it out here, and you're only creating more work for yourself. You'll have to add more dimensions to make sure it doesn't go away. And that's a lot of work that you don't need to do because you don't have a reason to do it. Now, there's another thing that you could have asked, which is, why didn't we put the corner of the rectangle on the origin? And I'll say that is largely a preferential decision to make. I like to put the rectangle centered on the origin because that really helps me out in the future in case I want to revolve something around the origin, or if I want to do a pattern or mirror something across a plane. If you start with the corner of your rectangle here, and then you do some imaginary feature that needs to be mirrored over to the other half of your part, you don't really have a good plane for that. So I like to start with my rectangle centered about the origin.
Got it. All great comments. I agree with everything.
Cool. So in this case, I've already dimensioned both of the sides in this rectangle, but just for fun, I'm going to delete these and we're going to go through them together to make sure that we cover everything. First off is, in order to do a rectangle, to dimension a rectangle, you can click on just one side and drag out your dimension and click. Here you can type in any dimension you want. I'm just going to pick 4 for right now, 4 inches.
Which mouse buttons did you use to click and drag and drop off your dimension?
You can see on the bottom of my screen when I do actions, my computer shows the buttons that I'm using in case anything's not clear.
Oh, cool.
But, when I click here, it's just the mouse 1 button. I guess it doesn't show mouse 1 because it shows it around the cursor. You just click once on the line you want to do a dimension for, and then it's attached to your cursor after you let go of the mouse button. Then you could put it anywhere you'd like. I like to put the dimensions outside of the sketch because it's very easy to see what's happening. If you get a lot of dimensions inside of the sketch mixed up with lines and things, it can be confusing. So I usually pull them out to the side and then click once, and then this window pops up for you to type in. And then hit enter and the window will disappear.
And that was I know people can have different mouse buttons inside, but generally speaking, that's a left mouse button click, right?
Correct, yeah. Everything that I'm doing here will be based off of the default SolidWorks settings. In fact, my interface here should be the default SolidWorks interface as well. And
Great.
The background. Now, there is another way of doing a dimension like this that some might prefer. In fact, I do a lot of times. Instead of clicking on the straight line and then dragging out and clicking, you can also click from where you want to take a measurement and then click the other spot you want to take a measurement to, and you're getting a similar dimension. In the first dimension, I'm just going to hit accept there. This is defining how long this line is, and by dimensioning this way, it's defining what the distance is between this line and this line. It's a slight difference, but there are some sketch features that you might do in the future that could mess up this dimension. If this line gets shorter, then this dimension might mess up. Versus if you dimension from this line to this line, and then, some other weird features get put into here, then let's say I trim this dimension still exists. You'll see how the first one died because I had clicked on how long that line was, versus this one stayed because I had defined the distance between this line and this line. This is another preferential thing, but the way I do this top way because it's more future proof. I don't have to imagine what might happen in the future. I just do that, and if I do something in the future, I never have to worry about something breaking on accident.
Yeah, I agree. I do the same thing, and I would go so far as to say that's best practice to do it that way.
I agree. There's somebody recently I think is really good at CAD who doesn't do that. So I think I have a preference.
Sounds like they need to watch Pipeline Academy CAD Essentials.
Yep. All right. Now there's something interesting about this project though, and it's that this holder is going to hold a perfectly circular part. And the unique thing about that is I know that my holder doesn't need to be a rectangle, right? It's going to be this same dimension up and down. It is going to be left to right. So one thing that I can do is delete this dimension, and I guess I'll delete that dimension. I'll redimension this the right way. And now I can tell SolidWorks to make this line the same length as this line. And I can do that by holding Control and clicking on both of the lines. And then SolidWorks shows the available relations. Some of these might not work because of the way my sketch is done, but I do know that I want these to be the same length, which is the same thing as equal length. So I'll click on equal length here. And now you can see a new relation showing on this line, and the entire sketch is black instead of blue, and that means it's fully defined. And that means nothing can change on accident in the future. If any changes were to be done, they'd have to be intentional. And you could see where this line is equal to by hovering over the relation, and it actually highlights the other line and the other relation to show where that is. Okay, so this is my basic profile. I've put an arbitrary dimension in here, and we'll just move forward from this, and we might have to come back and change it. But let's go ahead and extrude it and give it a height. So again, I can exit my sketch if I want and then create the feature, or with the sketch still active, I can head over to the Features tab and just click on the Extrude boss or base. We've seen this before. It's just some profile getting pulled up in one direction, and I need to give it a height. So I'm just going to give it a random dimension here, let's say 3 inches tall. That sounds like it could hold quite a few coasters, so I'll go ahead and accept that. And now we have the start of our new coaster holder. Before we get too far though, I'll save it. I don't want to lose all the work that we're putting in here. I'll call it the coaster holder. Okay. So now we need to do something to this so it can actually hold a coaster. If I put a coaster on top, it's just a really thick platform, but I want to put a hole in there so that we could stack a bunch of coasters without them falling over. And there are a couple ways we can do that, but I'm just going to start by selecting the top face, and then I'm going to draw the shape of the coaster and then cut into it so the coaster will fit. Before we do that, I need to remember how big that coaster was, so I can switch over to that part. If you remember, it's still open. I think a lot of people like to go to Window and then look at the list of things that are open here. You could hover over them to get a preview. So that's certainly a way you can do it. I'll tell you in a second how I like to do it, but you could select the outside of the coaster right now, and you could see down at the bottom of the screen, it gives me the measure of the diameter. So the diameter is 3.25 inches. So we need to make sure our hole is bigger than 3.25 inches. So we could write that down or just remember it for now. Now you could go back to Window and then select the coaster holder to go back to it, but I want to show you how I usually do it. I like to use the keyboard shortcut Control Tab. So if I hold down Control and hit Tab once, I'm still holding down Control right now, but I can actually see the other files that are open, and this is how I usually switch between documents. So if I hit Control Tab once, it'll go to the last document that I have open. And that's how I usually switch back and forth. But maybe when you get started, you can just start by using the window option to switch between them.
And I would consider that like, I don't know, kind of like a pro tip maybe, because it does make it faster, but you have to know that shortcut exists. And in general, using keyboard shortcuts is just so much faster and more efficient. So I think Brandon would agree that we encourage people to learn, maybe half a dozen or a dozen really common keyboard shortcuts or hotkeys and use those, because it really does make the workflow much more efficient.
Yeah, exactly. Yeah, for me, I use shortcuts a lot in Windows and in, browsing the internet. So for me, that was a thing that I learned very early on in SolidWorks. But for people who are not as used to doing keyboard shortcuts, you could certainly start by using as much of the graphical interface as possible. But as you continue to develop, you're going to realize that SolidWorks requires a lot of mouse clicks with your one hand. And anything you can do to offset some of those mouse clicks to the other hand, you're going to love, because it'll save time, and it'll also, save your fingers from clicking too much, and even save your arm from moving around too much. Okay, so we're back here, and we measured our coaster at 3.25 inches. I'm going to create a cut from the top surface by selecting it. I could go to the sketch tab, or I could just move closer to this and select the sketch option. There are a lot of other options here that you're welcome to explore, but we'll get to them as we need. So right now I'm going to use the sketch option. You can see on the left side that SolidWorks created this new sketch, and as a reminder on the top right, it shows that we are currently in a sketch. So I can look straight to the surface again by clicking this option here and selecting from the cube what view we'd like. Another option is you can hit the spacebar to enter this menu, another keyboard shortcut. This is a really popular one though. The spacebar not only shows you the available views to select from, but it also shows you this orientation thing that you can experiment with if you want, but you don't really need to use it because it's all shown here. So I'll click on the top here and look at our sketch. I'll create a sketch entity of a circle by selecting circle up here and clicking at the origin once and letting go and moving out some amount. And then I can type in the radius right now because this is highlighted after drawing a circle, or I could just ignore that and then come up here and go straight for a dimension. So now that I have the smart dimension selected, I will create a dimension for the circle, and I know that it needs to be greater than 3.25. So you could just type this dimension here and cut this hole. This is something I probably wouldn't do. I would do something slightly different than this, but this is a good beginner step here. Just make sure that your hole is bigger than the item that you're putting in it, and we'll talk about some more advanced strategies in the future. Right now, I will do a cut here and make sure I don't cut through the whole part. Let's say I do like 2.5 inches. You can see the preview here. This is the bottom of the circle that's being cut, and we're not going through the block, which is just fine. So I will accept that. So now we have what could be a coaster holder. It's a big hole in it. It's bigger than a coaster. It's taller than multiple coasters. So let's create an assembly for this and drop some coasters in. So I'll start by saving it. You could hit the save button up here. And then we need to create an assembly out of this. So you could do the new, I guess I have a tab over here you probably don't have. I could create an assembly from here, but this is just going to create an empty assembly. What you could do instead, you could cancel out of this. And instead of clicking the new button, you can actually click the down arrow next to it, and you can create an assembly from this part. which is really helpful because not only will it create a new assembly, it will open up a dialog that lets you drop in any parts that you already have open. And so that saves you a couple more mouse clicks. So again, I'll just click the arrow next to the new icon and make an assembly from that. And now I can just hit OK. And then now you can see in this list all of the stuff that I have open. So I've got one assembly open and 2 parts, and you could tell because of the icon on the side. This is sort of the SolidWorks universal icon for part, because you can see it's just like one item, and then this icon is the icon for an assembly because it's got 2 items stuck together. So you could see easily here I've got these 2 parts and then this assembly open. Now this assembly might have 25 parts in it, but if they're not all open in the background individually, you won't see them in this list. There are a couple things you can do here. One thing is select an item and then hover over the viewport. Select an item and hover over the viewport. Does this work different? Did I mess something up? Oh, graphics preview. There you go. There it is. You select this is the item we're using here. You could hover over the preview here and then click, and it will drop the part into the assembly where you've clicked. The only problem here is, you're just clicking out into space. You don't really know where the origin is, and generally, especially this coaster, is sort of like the anchor of the assembly. This is, if you can imagine the coaster being the focus of the assembly, when you use a coaster, it doesn't move. The stuff that you drop in it does move. So I'd like to put my coaster at the origin. You can make an argument for something else, but I think in this case, you just want to make the coaster at the origin. A way you can do that is you could just click and drop it randomly in space and then use mates to put it in place. Or you could just have it highlighted in this list and hit OK. And you can see when I moved to that, it snapped it to a spot in the viewport here. And that's because that's where the origin is. So if I click on an item on this list and then I hit OK, SolidWorks will center it on the origin. Basically, it's going to put, if I expand the feature tree here, it's going to make the origin of the part where the origin of the assembly is. And for any assembly I can think of, you want to have one part where the origin of that part is on the origin of the assembly. Like I said, this coaster holder to me is sort of the anchor of the assembly. So if I imagine somebody using it, I don't imagine this coaster is moving. I just imagine somebody's putting the coasters into the holder. So I have selected that option and hit OK, and now I know this origin and this origin are in the same spot. Anything, was that clear, Aaron? Do you agree with that?
You may have said this. I'm just going to reiterate if you didn't, or if you did. You mentioned that you pretty much always want one of your parts to be centered on the origin, and I just wanted to restate that the part you choose to be on the origin is often going to be one of the foundational parts of your assembly.
Yeah, that's probably better. I was calling it sort of the anchor of the assembly, but foundational sounds better probably. So that sort of is quite often kind of like that bottom part that everything is stacked on top of.
Yeah, that a lot of the assemblies we do are like test fixtures that have a base plate, and they're 10 or 15 parts that are assembled on top of this base plate, and so we'll use our base plate as that foundational part and make sure that's centered on the origin in our assembly, and then everything else assembles onto the base plate, for an example.
Yeah, exactly. Yeah, so you really want to avoid having them float out into space. That's a thing I see a lot, and that just makes things difficult, and you'll see later potentially in the lesson why having this centered is very helpful. Now, before we get too far, I of course want to save this new assembly just in case my computer crashes or some unforeseen circumstance messes up all my hard work. So I'll hit the save button here, and it asks me if I want to rebuild the part before saving, and all that's asking is SolidWorks isn't quite sure if there were any changes to the parts. So it's just going to ask you if it wants to check the parts before saving them. I usually hit yes. And then we can name it. So I'll call this the coaster holder, and then I'm going to give it an abbreviation for assembly. Okay, so now we have an assembly with one part in it. That's certainly an option, I guess, but we want to put some parts into it to make it a true assembly. So we have to bring back that dialog that we had before, the feature where we could drop in the manager, where we can drop in additional parts, and that happens to be up here on the assemblies tab. It's called Insert Components. So if I click that, it will again show us anything that we have open. We can obviously browse to somewhere on our computer to insert a part that's not open in the background, but the easiest thing is just to make sure you have it open already, and then you can just select it. So here I've got the coaster. I'll click this once and then move my cursor out into the graphics view here, and then I can just place it anywhere I want.
Why don't you just select the green check mark and automatically have that coaster centered on the origin?
That's an excellent question. Let's see what that looks like. If I select the part from the list and then hit the check mark, you'll see that this part is fixed in space. And generally, you certainly don't want to have, in this case, the coaster fixed in space. And if I use my middle mouse button, press down to float around, I can actually see the coaster down here, and there's obviously something wrong. It's inside of the block. And that's because SolidWorks has mated the origin of the coaster to the origin of the assembly, and that's not very helpful for us. We want to put some thought into where the coaster sits, and that's going to require us to tell SolidWorks exactly what mates need to happen. So I'm going to delete this, and then show you how I would have done it. Just confirm this delete here, and I'll do a new view here. And let's insert a component. I'll click the coaster once, and then move out into the viewport, and then click one more time. And now you can see it's sort of approximately located in the right place. And of course, you'll see next to the name in the list here a minus sign, which means it is not fully defined. And that's a good indication that we have some more work to do.
What does it mean when you say fully defined?
It just means it can move. So if I click on it and move my cursor, the part moves. That's another indication that the part can move. Reason why this is important is because, especially in really large assemblies, if you have 200 parts and you don't have everything fully defined, let's just say you kind of just drag this in here and it looks okay, and you call that good, and then you put another 100 parts in there, you might not realize that something doesn't fit properly, or that something broke at some point. If your everyday practice is to make sure that everything in your assembly is fully defined, and then you open up the assembly later and you see there's a minus sign next to something, you know that that's a red flag. Something has gone wrong, and you need to then investigate the problem. If your feature tree is just filled with a bunch of stuff with minus signs, just like in parts, if your sketches are filled with minus signs next to them, you've kind of missed out on the opportunity to use that as a tool to give you a red flag when something has gone wrong. So that's why we generally try to fully define our sketches and assemblies. So as you can see here, SolidWorks doesn't do a great job of detecting interference between parts. In newer versions of SolidWorks, I think starting with 2019, there's a feature that will allow you to kind of like bump these parts into each other. But in general, SolidWorks isn't quite sure what you're trying to do. So it's not going to tell you, no, you can't put the part, intersecting with the other part, because maybe you are trying to do that. There are some cases where you will do something like this. And so SolidWorks certainly isn't going to tell you that it knows more than you do. So we can start with this part at any position. In fact, we could just start by having nothing selected, and we could click the mate tool here up in the assembly tab, and a new mate manager opens up here with this first box selected. And now we want to think about what we want to mate, and then select those options, and then make sure that SolidWorks picks the right thing. So in this case, I want to make sure that the coaster is centered inside of this circle, and that's a really easy one to do. I'll click on the whole circle here. SolidWorks will make the part transparent because you can only select one thing to mate to in a part. And then I will select the other associated surface here, which is going to be the outside of the coaster. I want the outside of the coaster to be what we call concentric with the inside of the holder. And concentric just means that the center point of the circle is in the same spot, so that you can see in this icon, it kind of shows you what a concentric circle looks like. They could be a different size, but they're sort of always with the same center point. I've never had to describe that before. Okay, so I'll hit green to accept it. And you'll see that the part was moved in that process, and it is concentric with the hole, which is perfect. And you might also notice that the mate manager here is actually still open, because usually when you start adding mates, you do more than one at a time. A lot of the other features we've worked with, it'll close automatically when you hit OK. But there's this option here that is usually on by default, and it will keep this open until we close it. So I want to add another mate in here, and this one might be a little bit harder to do because we want to set the coaster on the bottom of the hole, and we can't see the bottom of the coaster. So even with the mate manager open, I can click and hold on the part and move it up, and I'm not actually selecting that surface. There's a small difference. If I click once on the surface and let go quickly, I can actually select that for a mate. I'm going to clear that. But if you click and hold something, SolidWorks kind of gives you a pass and lets you move it around and then let go without actually selecting it. That's a really handy thing to be able to do. So if I want to stick the bottom of the coaster to the bottom of the hole, I'll just click on each one of them, and SolidWorks has guessed that it will be coincident, and it's a pretty good guess, so I will accept it.
And something interesting happened there, Brandon. When you selected that first part, it turned transparent. Why might that be helpful?
I did mention that a moment ago.
Sorry, I just missed it.
It's fine. It's probably worth repeating that when you're creating a mate, it has to be from one part to another. I can't tell SolidWorks to bend this side of this square, this rectangle, to this side of the rectangle. It's just not possible. So as a visual indication, SolidWorks has made that part invisible, because once you've selected it once, you can't really select it again for most of our basic mates. Now there are some more advanced mates here that we'll talk about in the future, but this is actually a really handy thing, because if I undo, so I've undone that mate. So let me show you what I could have done instead. So if I drag this back into here, and I want to create a mate between the bottom of the coaster and the bottom of the hole, I can click the mate button, and I could peek in from the side of the coaster and click on the bottom of the hole. And now that SolidWorks knows that I've selected that surface, I could actually peek through the block itself and select the surface I want. So that's a really handy thing. So now if I click here, it actually doesn't click the block, it reaches through it and clicks on the coaster. And now I can hit accept. And I've done the same thing that I did before, but maybe in fewer mouse clicks because I wouldn't have had to drag the coaster out of the hole first.
Now, what if there's a third way that honestly is less useful than these two ways that you've shown, but sometimes it's all you have left? What if you're not able to use transparency to select through, and you have to select a face that is not like directly visible to you? How else could you select that face? Do you know what I'm getting at?
Yeah, I think that's probably a more advanced thing, but we can talk about that. Let me undo this. So we don't have a good example for it now, but it does pop up quite often. And it also pops up when you're modeling parts and things, and it works the same way. If I need to select a surface that's out of view, let's say I need to select the bottom of the hole, but I can't find it right now, I could hover my mouse to about where I think that surface is, and I can right click and do select other. And what this does is it hides the surface I was pointing at, and it shows the one directly behind it. So now I can select the next one. But this isn't the bottom of the hole, it's the inside of the hole, and I didn't want that. So I can right click one more time and it'll hide that surface. And now I'm looking at the bottom of the hole. You could tell that it's highlighted. That means it's, it's, if I click now, it will select the bottom of the hole. So I'll do that. And that works just the same way as if I were looking directly at a surface. So you use this right click, so do it again, right click, select other, and then you just keep hitting right click, hiding the surfaces that are in the way, kind of peeling away the layers until you get to the one that you want.
And can you also point at that little pop-up menu that appeared?
Yes, you can, and that has mixed results. In this case, looks like this one will work. A disadvantage to this is it does not hide those surfaces that are in the way. So you can see now, I can't point to it because it'll go away, but you can see that circle is highlighted now, even though it's behind surfaces that are in the way. So I could select that, and it's still selected. I'm no longer in the mate option, I guess, but if I hit mate while it's selected, it's pre-selected now. So you could do any of those two ways. We hit on it a lot, but it's really important to know that there are so many ways to do things in SolidWorks. We're going to show you the best ways to do them, but there are always going to be like niche reasons to do something slightly different, or even just your preferences that make you do something slightly different. Probably the best way to do this would be to hit the mate option, select the bottom of the hole, and then select the bottom of the coaster. But if you could use any of those other ways to do the mate, do the same mate in a slightly different way. Okay.
Awesome. Thank you.
Okay. Just a little bit more on mates, because this part is really important. If you remember, I said that a long pile of parts in an assembly, if some of them have the little minus sign next to them, it will be difficult for you to know when something's gone wrong in the future. So this part still requires another mate to lock it down. It would be difficult for me to show you because it's round, but I can actually rotate this part because it's circular. I've not given SolidWorks any rules that prevent it from rotating. And I could show you that it rotates pretty easily by expanding the feature manager here and showing one of the planes. So let's say I want to show you the front plane here. You could see that it's just like the outline on the icon, which means it's not visible. If I right click on it, there's an option to show it. And you can see that it's showing here, but for some reason it's not showing in the viewport, which is another really good thing to talk about. I think we briefly discussed it in the first lesson, but in this option here, I could click at the arrow next to the eyeball, and I could see the icon for planes is not selected. There are a bunch of other things selected, but I want to select view planes. And now I could see the plane in this coaster. So I just showed this so I could show you that if I rotate the coaster, it is actually rotating. It's kind of difficult to tell because there are no features to show you that it's rotating, but now you can see with that coaster. So there are a couple ways that we can prevent this from rotating. The easiest way to do it is when you created this concentric mate. Or I guess I shouldn't glaze over this. This mates list at the bottom of an assembly will always be there showing you how your parts are stuck together. If I collapse this, you'll see a list of the parts and assemblies that are in this assembly, and then at the bottom here you see mates. And I could extend this to see all of the mates that are in the assembly right now. There's the concentric mate that we did. If I select it, you can see what items are concentric. And then there's the coincident mate that shows which items are coincident. I am going to edit the concentric mate by right-clicking and hitting Edit Feature. And one thing that I could have done when I created this feature was select Lock Rotation. This is a feature that was added in the past probably 3 or 4 years, I don't remember, where not only will it make the two faces concentric, it will prevent them from rotating relative to each other, which means that's that missing thing that will prevent this part from rotating. So now you'll see that minus sign has disappeared next to the coaster. And in fact, there's a slightly different icon that shows that the not only are they concentric, but their rotation is locked. This is something you can do. I don't do it a lot because it makes things kind of off kilter. Certainly this circle, we don't care what orientation this coaster is in the holder, because who cares that this is rotated 25 degrees in one direction. It doesn't matter that much. But another way that you could do this, if I undo the change that I made, is you can just select one of the planes in the assembly and make it parallel with a plane in this assembly or the part it's mated to. So just for this purpose, I'll select this plane and I'll select, say, the front plane of the assembly, and then I can make these planes parallel to each other, and that will also prevent the part from rotating.
Now you mentioned that you can use planes to make that mate selection. Could you also use faces of the parts?
Yeah, you certainly can, and they are done a lot, but in this specific case, the reason I needed to use the plane is because there was not a face on the coaster that I could use. So, well, in this example, I can't give you a great example of having a face on one part being parallel to a face on another part, but that happens a lot.
But you could have, just for another example, you could have selected the front plane of the coaster, just like you did,
Yeah.
and then selected one of the flat vertical faces on the holder, right?
Oh, sure, yeah. That's definitely an option. That's probably a pretty safe option, but the reason why I avoid it is because if I go in here and I change this square part to being a round part, I don't want to have to rebuild the assembly. If I delete this face in the part itself, then this mate would break, because SolidWorks would look at this plane and it would try to make it parallel to a surface that no longer exists. So
Very good point.
Anytime I can make a decision like that doesn't take a lot of work, I do. If I had to think too hard about will this or won't this, I won't think too much about it. But in this case, it's just very simple to mate these planes together, because that part is probably always going to be built from the ground up, so that should always be locked in that rotation always. Now in this case, I mated it to the assembly plane, which I wasn't going to try to get too deep into, but I probably would have actually mated it to the plane in the part itself by dropping this down and selecting the front plane of the part. That way, if for some reason I decided in the future to flip the coaster holder on the side in the assembly, it wouldn't break the mate. So what that would look like is if I click on the mate down here and hit delete, I could create a new mate. I could select the plane that we showed earlier, and then I can't see any other planes, so this is like a temporary feature manager that pops up. I could click the down arrow here, and then now you can see I could select one of the planes in the coaster holder itself. So I probably would have selected this one and then accepted it. There you go. So there's no minus sign there.
How come you were able to select a coincident mate where you had to use a parallel mate before?
That's a good question. Before, I did not have to use a parallel mate. I chose to use it. Again, this is another thing. I actually just accidentally selected a coincident mate. I normally would not use it because, again, I don't have a reason to. All I want to tell SolidWorks is these parts can't rotate. And all that means is I want the two planes to be parallel. I've already prevented this coaster from moving around from side to side with the coincident mate.
Concentric.
With a concentric mate, and a parallel mate is enough to prevent it from also rotating. A coincident mate also happens to work because of the nature of the concentric mate, which is kind of confusing to say. I don't have a great way of explaining that, but a coincident mate happens to work, but it doesn't need to be used. So I usually will just make this parallel because who knows, maybe there's a reason why I might offset the circles, or maybe maybe that circle will be offset in the future, and then that actual mate will be broken. I could actually show you an example. If I changed that this hole cutout wasn't centered in the square, it was shifted towards one of the corners, a coincident mate would actually stop working, and then the assembly would have a bunch of red flags on it. So a parallel works better because there was no reason to tell it to be coincident.
So would it be correct to say that in most cases, a parallel mate could be considered like more forgiving or less stringent than a coincident mate, and given the choice, you would choose the less stringent mate?
Yeah, especially in this conversation about keeping things from rotating, I almost exclusively use parallel because you're usually putting a screw through a hole, or a washer on a screw, and you're going to be using a concentric mate, so I always just use parallel.
Got it. Great.
All right. Aaron had to take a meeting, so I will continue this lesson on my own. Also, this is running a little longer than anticipated, so while we were going to change up the way this assembly was built, I think we're going to tidy it up and end it here so we could move on to the next lesson. So now that we've finished setting up the assembly, I want to make some improvements to this holder. Right now, the only way that you can get to a coaster inside would be to kind of turn it upside down and dump it out, because there's not enough room around the outside of the coaster to stick your hand in and pull it up, and it's really deep. So let's see if we can make some improvements to make it where it's not really annoying to use. So I will switch back to this part. Well, the first thing I want to change about this, I think, is that this doesn't really fit the look of the coasters, and I want to have them look like they're kind of the same kind of product together in an assembly. So I think I want to change this to a circular block instead of this square block. So I can go back to the original feature and edit the sketch, and I am going to delete this and replace it with a circle. So this is 4 inches, so I'll go ahead and just select everything and delete that, and just draw a circle and give it a dimension. There we go. If I close out the sketch, the hole is still there because that was controlled from a different feature, but I didn't change how the boss was built. It's just a different shape now. And if we look back into the assembly, nothing has failed because we set up our mates appropriately. And now we can think about how we can improve this design to get at the coaster. One thing might be, let's make it a little bit shorter. So if I open up this coaster, I can remind myself how thick this was. It's currently 0.3 inches. And if you want, you can go to the Evaluate tab and click on Measure to do the same thing, except this tool is a little bit more robust than just looking at the bottom of the screen, because it will show you more decimal points, and it will also show you a variety of other details that may be interesting to you. So there are other features that we'll talk about in the future, but right now we're just using it for the distance between these two highlighted surfaces. If I had selected the wrong surface, I could either delete it from this window and then select a different surface, or I can click into the empty space behind the part and it deselects everything, and then I can click on other stuff. So we just measured that at 0.3 inches, and if we're thinking about a coaster holder, we might want it to hold 4 coasters probably. So let's change the height of this to be just a little bigger than 4 coasters. If I edit this feature, I can say 0.3 times, let's say it's 4 coasters, and then I'll add a 1/2 inch. So you can put some simple math in these boxes and SolidWorks will convert it. So there we go. Now we got a slightly smaller coaster holder. And if I Control Tab over to the assembly, you can start to see how easier it might be to grab that coaster. So now we've got a problem with some mates here, and we need to figure out what the problem is with that. So I will expand this, and we have a problem with the coincident mate. And if we look, it's because the bottom is missing from the coaster holder. And that's because we did not have good design intent with the way we set up our assembly here. This cut is just an arbitrary depth. We just set it to 2.5 inches deep, which means if the height of the coaster holder got shorter, then we'll still just cut all the way through the bottom. So we can change the way this dimension is done, knowing that we will always want a minimum depth, or sorry, a minimum thickness of the coaster holder. So what I'm going to do is change blind, which is to say the blind cut just will cut regardless of whatever is happening in the part. You know, it's just blindly cutting through stuff. And I want to change it to offset from surface. So with this box selected, I could select a surface, and then I could tell SolidWorks to cut all the way until some offset. So let's say I want this part to always have 1/8 of an inch of thickness at the bottom. It will show a preview here that it will always cut to that offset. I'm actually going to change this, maybe a 1/4 inch, and accept it. Oh, actually, before I accept it, I do want to show that it's possible this won't do what you want it to do. It might cut to a 1/4 inch on the other side of the surface. And if that's the case, then you can toggle this button here, reverse offset. So it's just going to trade the side that it's cutting to. So now it's cutting to a 1/4 inch off of the other side, which is great. This could also work on curved surfaces if you need it to. So I will accept that, and we'll go back to the assembly. And you can see the mates have fixed themselves because we now have a bottom to our coaster holder. And everything's good to go. So we thought about this having 4 coasters in it, so let's go ahead and place them in there. You could do an insert components and grab the coaster and drop it in. Or you can hold Control, then click and hold on a part and drag it away from it, and that will create a copy. Same thing happens in the feature tree. I can hold Control and then click and drag and bring a copy into the graphics view here. And you'll see every time I do that, it creates a new listing for a part in this feature manager. So I will now start adding some mates to get these into the right spot. Remember, I'm going to want to keep these from rotating, so I will go ahead and show a plane, just like that. And I'll do the same thing with the coaster holder. So let's start mating some stuff. First, concentric mate. I'll hold Control and click the outside of the coaster and the inside of the hole and hit concentric. And then I'll click the top of this coaster and the bottom of this coaster. Oop, I forgot to hit Control. There we go. And I'll click concentric. And I'll grab this and grab this and hit parallel. And now that is ready to go. In fact, if I close this up, you'll see our second coaster is fully defined. And we still have 2 more coasters to go. There is one other thing that you can do instead of these. What I'm going to do is I'll select both of them by holding Control and clicking on both of them and hit delete. Okay. There is a sort of advanced feature, so you can remember where this is and come back and look at it later, or you can follow along and use this tool in the future because it's very helpful. If you right click on a part, you can actually click this option called copy with mates, and what that means is it will create a copy of this part and it will duplicate any mate that it has, but before it accepts it, it will ask you if they are good to go. So let's see what that looks like. If you click on copy with mates, I had this part pre-selected. It looks like, there we go. Don't worry about that. Normally that's not down there. It's something I must have done in a previous lesson. Okay, so I have selected the mate, the part that I want to copy, and now I can click this next arrow, and these are the 3 mates that the original part has. If there were more mates, you'd see more of them down here. And what I can do is select the different, I could change anything that's different. So we know that the outside of this coaster is concentric with the inside of the hole. We like that. So what I'll do is I'll click repeat because I want the new coaster to also be concentric with the inside of the hole. The next one, we know that the bottom of the, you can see in the preview here, the bottom of that coaster is connected to the top of the coaster below it. We don't want to repeat that. We want it to be connected to the next coaster up. If I click repeat here, the third coaster is going to be stuck to the first coaster, and that doesn't make any sense. So what I'll do here is I'll replace the mate by just selecting on the new thing that I want to replace it with, which was that surface. So you can see there, I've got I've selected the top of the second coaster, so the third coaster can sit on top of it. And then the parallel mate was just to keep it from rotating, and we want this one to not rotate, so I'll just click on repeat. And then now that all three of these have been fully defined, that third coaster becomes solid in the viewport for you to see what's going down. And I'll accept that. Now, because I have this pin selected here where it says keep visible, this feature of copy with mates still shows, which allows me to then do another copy. I could just X out of this if I was done, but I would like to create another copy of this part. So you can see the repeat mates are still selected as repeat. So all I need to do is remind SolidWorks that I want the new coaster to be connected to the top of the previous coaster. So if I have this box selected, I can click on the top of the third coaster, and you'll see my fourth coaster has gone solid. I can accept that, and I could keep going and make as many as I want, but I like 4 coasters, so I will just X out of this command because I don't want to add any more. And now I can hide these planes because we're done using them. And you'll see I have 4 coasters all fully defined, and these are all the mates that keep them in place. I'll save my work. And it's starting to look a little bit better. We still have not solved the problem of getting to the coasters, and that's an easy fix here. All we need to do is either make it completely oversized, or we can just cut some little features out of the side of the tray to so that you can just kind of grab it. So let's go on over the coaster holder here and think about what we want that to look like. So I am going to look at the top plane. And in fact, I'll sketch on that plane. I don't have to click the create a sketch button. I could just start clicking on sketch entities, and when I do that, SolidWorks will open the sketch for me. And I'll just do some reference lines here. And what do we want this to look like? Let's do something really simple. I'll do a center rectangle and click on the center line here. And I'll give it a good width. What's a good width? Let's say something like that. And we just need this cut to come in just enough so you can catch the edge of the coaster with your finger. So what I'll do is actually drag this until it lines up with that entity. And we'll be cutting through here, so this line doesn't really matter because it's not going to cut any material away. But we do want to make sure that if the diameter of this coaster ever changes in the future, maybe it gets really big, we don't want this to drift inside of the part if that diameter gets big. So what we'll do actually is I'll select this line and the outside of this circle and make those tangent. That way it always moves together. From here, I'll do an extruded cut, and I can't really see what's happening, so I'll rotate that back a little bit. You can see the cut's going in the wrong direction. It's cutting downwards in that preview, and you can see the arrow showing that. Now you can just click on the arrow and let go, and now you can start, you can see in the viewport here what's happening. Or you can come up here. Now, we're doing a cut through the whole part. That's like the definition of what we're trying to do. We're trying to cut through the whole thing. So instead of giving it some length that if the height of the coaster changed in the future could potentially break, I like to do a through all. And that just means cut through all of the material in this direction. So the arrow is pointing up, and that'll be through all. And I accept that. And then now we can go look here. So you can see the cutout gives you access to the side, so you can pull that up. But it doesn't really give you good access to that bottom one, so maybe we'll make that cut a little bit deeper to get underneath that bottom coaster. That should be an easy fix. I will edit this sketch. Not the name of it, I'll edit the sketch. Look normal. And right now you can see that this line position is defined by sticking this point to this line. So I'm going to select that relation and delete it. And bring it in just like this. And I want to, well, we'll just do this. Make it go in 0.65 and accept it. So now if we look back at the assembly, we can see there's a nice little ledge underneath this bottom coaster, which means you'll always be able to reach in there and grab that. It's kind of awkward to only have a cutout on the side. Maybe you want to pinch it with your forefinger and thumb here. So I'll go back to the part, and I want this cut to happen on the other side. Somebody might want to edit a sketch and just add another rectangle to the other side, but then you're making your sketch unnecessarily complicated. You don't need to add all those extra lines. You can do this easily with a feature, and we'll do it with the mirror feature, although there are a variety of other ways to do it. So I can just click on the mirror feature, and it asks me, where do you want to mirror it across? You know, what if this is a certain distance from one plane and you want it to be the same distance on the other side of that plane, which one will that be? So I will expand this tree here, and I'll look at my front plane. That doesn't make any sense. If this part is mirrored over this plane, that feature's not going to do anything. Also doesn't make sense for the top plane because that's just going to mirror it down into nothingness. But if I look at the right plane here, that should work. And one thing that might help you make this decision is if you started by selecting the feature you were going to mirror. So I can select it here from this tree, or I could actually click on it in the graphics view here, and you could see the preview on this side. So if you weren't quite sure which plane you would like to use for this mirror, you could have selected this and then gone up here and looked at the top plane, and that doesn't look right. Or look at the right plane, and that does look right. So I'll accept this, and then we'll go back over to the assembly. And now this is starting to look a lot more useful. The coasters can't fall out, but you can get your finger in there, you know, one on each side, and pick them up. That's pretty handy. There are probably a lot of different ways I would have done this that would be different than this, but we'll stick with this for now. So it's starting to look, it's certainly more functional. It's looking a little bit better, but let's do a couple final things to make it look good, because we don't want it to be just some boring piece here. We could look at our coaster for inspiration. It's got a chamfer on the outside and some nice fillets around everywhere else. If I wanted to match this, I can double click on it. It's 0.1 at 45 degrees. So I'll select the chamfer feature, click that outside line and that outside line, change that to 0.1, accept it, and then we'll do some fillets. I don't remember what those fillets were. Let's say 0.2. Select some of these lines. I'll accept this. And let's go back and look at this. Double click 0.05. And that's 0.05. So if I right click in an edit feature, I'll add this, And we'll change this number to 0.05. I might as well throw in this one. Great. This is a pretty abrupt feature here. For machining, if this was going to be a machine, this would need a fillet, but it's also just kind of ugly. So we'll talk more about machining in the future, but for now, I'll just select these lines. Now, one thing I can show you is a somewhat new feature in SolidWorks, added like in the last 5 years. If you select a line and let go, there's some of these options here where SolidWorks is going to guess what other lines you could potentially select. And a lot of them are not very useful usually, but some of them will be useful. So you saw that I selected these 3 corners so far. So the next corner I want to select, if I just keep going over this, you can see right now it's highlighted. The final edge, I can't point to it because it goes away. But if I click that now, not only did I select that one, it pre-selected that. So that's a pretty helpful thing. I could show you again. If I clear all my selections and select one edge, I can go up here, and SolidWorks has just kind of grouped some features based on what it thinks you might want. And if I keep looking around, I can see how those are selected and try to find a good combination. So the closest thing right now is this one. And I could do the same thing here. And sometimes that selection is really smart, and sometimes it's not particularly helpful, so you could just decide when you want to use it and when you don't. I'll accept this. Actually, you know what? I'll edit this and make it a nice big, nicer looking feature. We'll add a little fillet in here, just like that. And we'll do this last one, maybe make that a little bit smaller. And you'll see that when you're adding fillets to areas, even though they continue to, even though you might turn a corner, SolidWorks by default has tangent propagation turned on, which just means if it reaches any line that's tangent, it will assume you want the fillet to also go onto that line. And in most cases you do. Most cases you want to have your fillets look real nice and smooth and continuous, so you'll just do this. If you didn't want to, you could turn that off, but that often creates some geometries that don't work, so you'll see the preview here completely doesn't show any fillet because it wouldn't be able to do this. So I'll reselect that and hit accept. And we're almost done. You can see I've missed this surface for a fillet. So I'll go ahead and select that to see which feature created it. And I could have edited it from the pop-up, or I could just right click and hit edit. I'll add that. There we go. And we can go back to the assembly. Great. So now it's starting to look a little bit more cohesive, the design between the two, right? The coaster and the coaster holder kind of look inspired by each other. I'll hit Control 7 to look at it in the isometric view to get a good idea of what it looks like. And I'm starting to like it. So I'll save my work and we'll move on from here. If you want to have a little bit of practice, I'd recommend creating your own coaster holder from scratch. Like I said before, I probably would have done this in a different way. I certainly would have considered the different types of manufacturing techniques that might be used to create this. But here we're just going through some examples and learning as we go. So we'll definitely go a little bit more in depth in the future. But that's it for lesson 3. See you back here for lesson 4.
If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer or a company interested in training your new engineering hires, Our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.